Thanks for joining us. So more specific to the latest trends of technologies, which is what is happening in PV industry, or even specific to ESS part. Let's go back to a decade back or 15 years back, where we could see that 110 by 110 mm wafer size modules used to prevail as a kind of major module segment. And it started from there as a kind of commercial module available in the market, and it went to a value of 156.75 with polycrystalline module as multicrystalline module. And then it went to 158.75 with mono-PERC technology starting from 2018 onwards. And then we can see that 163.75, M6 wafer size of 166, and then M10 of 182. And then now we can see that M10 is leading the market from front. And also there is G12, which is 210 by 210. And again, it is coming back to 210 by 182 kind of wafer sizes. So these are the technology optimizations which market has noticed. And within these particular different wafer sizes, what exactly is the wafer size which is going to rule the market or going to stay in the market for longer period of time? So just going in detail or in depth specific to that particular part, let me just introduce our company, just as a kind of brief introduction. Probably most of you might be aware about Jinko Solar. We are global leading solar PV module manufacturer, having delivered more than 130 gigawatt capacity by the end of Q4 of 2022. And more specific to the kind of market share, we hold beyond 20% in certain regions, and across the globe, we have a decent market share of beyond 12%. And altogether, this all is happening just because of the kind of technology leading aspect, what we have it as a kind of professional trait. So not everyone generally holds this kind of aspect, but yes, Jinko Solar always believes in being as a kind of technology leader, which is the reason why when entire market was standing at P-type kind of substrate technology specific to mono-PERC kind of technology with 550 watt peak as a kind of major power class, we were the first entrant to touch with a kind of power class of 575 to 620 kind of watt peak with TOPCon kind of technology, which is the latest in class. And we didn't stop ourselves just being in TOPCon. We even have done some kind of optimization within that particular TOPCon by just going with a kind of selective emitter kind of technology. That's what is going to happen for 2023. But yes, for 2022, we used to provide with TOPCon kind of technology up to 620 kind of power class. But yes, with this kind of selective emitter kind of technology, we can see that the efficiency or the power density within the module is going to be increased, and also specific energy density is also going to be increased. You can see this particular slide where in which P-type, which is nothing but the P substrate, was the major technology variant which was prevailed in the market, and specific to Indian market, we are still standing on this particular power class specific to 540, 550, 555 kind of power class with P-type variant, which is coming with 182 by 182 as a kind of major mainstream variant. Within this particular segment, if you just try to see, P-type is completely went into a kind of saturation mode, because within this particular 10 years kind of timeline, we can see that the kind of optimization, which is what is required on the fronts of power density improvement, which is increasing the efficiency of the module, and energy density improvement by just varying certain components of the BOM composition of the module, where we can achieve these kind of energy density kind of aspects. So energy density improvement can happen by just reducing the temperature coefficient, or even reducing your degradation factors, or reducing the extrinsity semiconductor activity within the module kind of technology can happen within that. So that way we can see that P-type kind of technology is completely saturated, where by just going with a kind of similar kind of TOPCon optimization within P-type probably can increase power density, but not the degradation parameters. So that way we can see that P-type is in a kind of obsolete mode, which is why people started investing, most of the peer manufacturers or most of the top tier manufacturers started investing more on N-type. And within N-type, we can see that the classification is completely happening in two different ways. One is towards TOPCon kind of technology, where it follows the same trend, same mechanization specific to the line manufacturing process as what mono-PERC technology used to follow. And similarly, if you just try to compare with HJT, heterojunction kind of technology, which generally comes with a kind of infinite bus bar, which is not so easy, which requires more amount of silver paste, and it has to be operated at a kind of reduced temperatures, which means, in short, the existing PERC lines cannot be utilized completely for HJT kind of technology, but yes, with little augmentation cost, you can utilize the same lines of mono-PERC technology for TOPCon kind of technology. And before TOPCon, there was a kind of technology which was PERT. We initially started with PERT kind of technology. We supplied to matured markets, and we had seen drastic results within that particular PERT technology, and which is why TOPCon prevailed as a kind of major technology for 2022. And going forward, for the next 2 to 3 years, we can see that this particular TOPCon technology is going to optimize much more, like what is going to happen with a kind of selective emitter kind of technology. And going forward, we can see that interdigited back contact kind of circuits can be expected, and with efficiency of around like 27, 28% kind of thing. As on date, if you just try to see specific to TOPCon kind of technology, laboratory efficiency it has achieved up to 26.4%. And specific to mass production, it has been touched around like 24.8%. And on the module side, if you see, up to 23%, 23.5% kind of module efficiencies can be expected. And this is all is happening specific to TOPCon kind of technology. And the kind of different product variants, what exactly we are supplying to markets across the globe is completely divided into 1I2 kind of wafer size kind of segments. Previously, we used to provide even with 163.75 wafer size kind of modules as well, but that is now superseded, and we are not providing anymore with Tiger series module, which used to come with a kind of tiling ribbon kind of technology, which has better energy density when compared with any kind of flat ribbon or circular ribbon kind of technology variants. And within this particular tiling ribbon, within this particular circular ribbon kind of technology with 1I2 wafer size modules, we provide in both P-type and N-type. P-type is there up to 630 kind of, up to 580 kind of watt peak power class, and within this particular N-type, which is called as Tiger Neo series with the same wafer size of 1I2 by 1I2, which means the same module dimensions of what exactly Tiger Pro series or P-type module is having, 2278 by 1134, the same dimensions will be maintained, but you can see that 30 watt peak extra power composition is going to be added, which means power density is going to be increased within this particular N-type or TOPCon or Tiger Neo kind of series kind of technology. And within this particular segment, you can easily see that 72 cell variants are going to be provided, and 78 cell kind of variants will be provided. And within 72, you can see that up to 580 kind of power class is expected, which can be supplied to any of your market needs. And similarly, with 78 kind of cell modules, specific to that, up to 630 watt peak can be provided. And this all is happening only within this TOPCon kind of technology, and that is coming with selective emitter kind of thing, which is what we are trying to provide only with 72 cell, which is why you can see that up to 600 watt peak, you can see within 72 cell module itself. So, and that is being provided in both monofacial and bifacial variants. So depending on your requirement, probably we can provide you with bifacial dual glass kind of requirements as well. And this is all more specific to module. And if you just try to compare the kind of advantages comparing P versus N, not just limiting itself, its benefit to power density, but even on the energy density side, you can see that the degradation parameters, more specific to P, it will be standing at 2% at the end of first year, and year-on-year degradation may be standing at 0.55% or 0.45%. The same thing if you just try to compare with N-type kind of things with TOPCon kind of technology, probably it will be standing at less than 1% for the first year, and at the end of every year, you easily can see that 0.4% irrespective of any kind of variant you easily can expect, whether that can be with monofacial variant or even with bifacial kind of variant. Not just limiting only to the factors of power density improvement or even on the temperature coefficient improvement, where with P-type it will be standing at minus 0.35% per degree C rise in temperature, and with N-type it will be standing at 0.3%. Just because of this particular delta of 0.05% variation in temperature coefficient definitely will increase your power energy density itself, not less than 1.2% to 1.8%. If you just try to compile all these particular factors, you easily can see on paper or even on your algorithm itself, you easily can see close to around like 3% of extra energy gain. This is what is expected on paper. And we did this particular analysis across the globe. And by just doing the NPV analysis and then putting in the LCOE numbers, what we easily could see is that the premium delta between P-type versus N-type, you easily can expect close to 2.5 cents to 3 cents. And this has been proved. Not just limiting only on the paper, but even we install these kind of installations just to have a kind of pilot reference-based installation specific to N-type. We installed across the globe, and in certain locations, like this has been validated and vetted by TUV Greenland, specific to location in Saudi Arabia, wherein which we easily could see that for 4 months kind of generation, we have noticed more than 5.5% kind of extra energy gain. This has attained comparing P versus N. And the same thing we even tried in doing in China, where the third-party agency was CGC. And within this particular aspect also, we had noticed that 4.5% extra energy gain has been noticed comparing P versus N. So this all is more specific to P-type or N-type kind of module, which is more specific to PV module segment. But yes, even Jinko Solar is trying to enter into this particular segment of ESS. we want to be as a kind of leader in this particular segment, and we want to address all kinds of concerns, what exactly is there, starting from RESS, starting from 1 kilowatt hour kind of requirements till megawatt hour kind of requirements. So starting with RESS kind of requirements, if you just try to see up to 1 kilowatt hour to 20 kilowatt hour, if your requirement is there, probably we can provide a kind of hybrid energy kind of solutions, or remotely managed locations also can be catered with this kind of off-grid kind of solutions. And not just limiting to that, even for the C&I kind of segment markets also, we have provided the cabinet solutions where we try to call this particular product as Sun Giga kind of solution, and Sun Terra is a kind of solution which we are trying to provide for utility scale kind of segments. And if you just try to understand the market specific to India, where the RTC tender or standalone tenders which are coming through GUVNL or SECI or NHPC or NTPC, all of these particular tenders literally asking for levelized cost of storage at the least possible factor, with high amount of RT, round trip efficiency at the AC side, if it is a kind of AC coupled system. If we try to optimize these particular parameters specific to LCOS, and that is getting interlinked to the pack management, because here what exactly Jinko Solar is going to do here is, we are not just trying to provide you a kind of simple product. We want to concentrate on this solution, not just like a kind of what we did with module, it's a product. But here, specific to these kind of energy storage aspects, we want to provide it as a kind of solution, which is why we targeted in providing starting from 1 kilowatt hour till gigawatt hour kind of solutions. And within this particular segment, you easily can see that on the residential segment, we are trying to provide with sun tank kind of optimized solutions. And more specific to utility scale and C&I kind of markets, we are trying to provide with sun tank, which is highly capitalized, more specific to low voltage application or even for high voltage applications. And also specific to the tenders, what exactly are coming with RTC or even for standalone tenders, which are coming from most of the other agencies, where these particular Sun Giga or Sun Terra kind of solutions probably make much more sense, which is coming with a kind of liquid air cooling mechanism, which is even having a kind of better prospects on the efficiency part, and RTE also can be very well managed. And this all is happening just because of the optimized design, what exactly we are trying to follow within our existing solution. So these are the specific technical particulars of a kind of sun tank kind of solution, which can be utilized for your residential applications as well, or even if your load requirement is limited only up to 20 kilowatt hours with a kind of continuous power requirement of 5 kilowatt, which means as a kind of 4 hours backup, these kind of solutions are even being provided with a kind of better intelligence mechanism, which in-house SCADA is being provided by us. So probably this can be utilized in these kind of sun tank kind of solutions. And more specific to Sun Giga or Sun Terra kind of solution, what exactly we are trying to provide is, we are optimizing our design more specific to the pack level itself. I understand that I'm running out of time, but still I'll just try to ensure that this particular slide is more effective for you, where it is having effective liquid cooling, higher efficiency, high safety, and intelligent OEM. So if these particular factors are being controlled, definitely LCOS of your system can easily be optimized. And more importantly, if you just try to see what exactly Jinko Solar is trying to do. So we are just trying to procure cell from the cell manufacturers, and module integration, pack integration with heat sink and rack integration. And within this particular rack integration or pack integration, what exactly we are trying to do is, automatic cutout is happening, whether it is linked with automatic charging or discharging, automatic cutoff is going to happen within this. So the moment whenever this is going to happen, it's going to have longer duration, which means the amount of cycles, whatever is being committed, is actually is going to be ensured with this kind of intelligent mechanism or intelligent design, whatever we are trying to provide. So altogether, cell itself is the only parameter or the only component which we'll be procuring, and rest everything is being completely done within our facility itself. So at the end of the day, it's a kind of system or a solution which Jinko Solar is going to provide to you, which is going to have a kind of smart management mechanism with highly efficient commissioning protocols, what exactly we are trying to follow. And on top of it, we'll be having a kind of real-time monitoring at our server level itself, which is directly getting connected to cloud. With this, I end the presentation, and thank you so much for your time.